So in this example, I want to focus on the use of parallel lines. That's really important in vector questions. They're used all over, and basically this is how they're used. If you know two lines are parallel and they're the same length, you know they're the same vector. So this vector b to c is also vector x. So just like this one, because they're parallel, b to c is parallel to a to e. Now how do I know this is parallel to that, or how do I know this is e to c is parallel to a to b? And we know that because when you stick equilateral triangles together, they make a whole load of parallel lines, and I can explain that very quickly. You should know about angles between parallel lines. That's an earlier video that I did, do check that out. And in short, it's basically if you have adjacent angles, that means two lines connected by another line here, and if you have an angle there and an angle there, and they both add to 180, then the lines that they're connecting, so this line and this line are parallel. So here's another two lines, a to b and e to c, and they're connected by this line a to e, and this angle here, if they add up to 180, then these two lines are parallel, and they certainly do add up to 180, these two angles, because we know equilateral triangles have all angles equal to 60. So this is 60, this is 60, this is 60, and even this angle at E over here is 60. So this angle and this angle are both 60, making 120. This angle is 60, so 60 plus this angle here, 120, makes 180. So I'm not going to go through that too slowly. Hopefully that made sense. If that didn't make sense, pause the video, think about it, replay the video, because I don't want to go through that too slowly. And if that really didn't make sense, do check out my earlier videos on angles between parallel lines on my website, sickmaths.com. Okay, so back to the main idea of this. Equilateral triangles, in short, make a whole bunch of parallel lines, and it's very easy to see where the parallel lines are, but also makes a whole bunch of equal vectors. So let's get on with the question. We want to find out b to c. B to c is the same as that line there, okay? It's the same distance and the same direction, therefore b to c is equal to x. E to c, that's the next thing we want to work out. E to c is over there, it's the same direction, it's parallel to a to b, and it's the same distance, so e to c is equal to vector u, just like it says over there. And what's next? C to D. C to D, well, it's from there to there. We also know that this is, e to c is u, e to d is x, so c to d is minus u, because it's going the opposite direction as the vector u. We know u goes upwards like that, so it's minus u and plus x, because it's going in the same direction as x, and it's the same as x. So, e to d is the same as x, so basically c to d is equal to minus u plus x. And finally, d to b, we're just trying to make it a bit harder here. D to b, you could take different routes. What route did I take for d to b? I could go this way, I could go that way, I could go all sorts of funky ways like that. I went d to a, I went the funky way, d to a and a to b. So d to a is minus 2x, as you can see that's an x, but it's the opposite direction of x, and so is that, obviously minus x as well, and that's obviously a positive u, so minus 2x plus u is the value of that, and that's how parallel lines are used. Now, a few more words. These equilateral triangles make parallelograms, so that's important to notice. Well, you can already see if you've got parallel lines, you can see this is a parallelogram, BEDC is a parallelogram. You get also a trapezium. Sometimes they don't show you the equilateral triangles, they just give you parallelograms or trapeziums. Either way, you've got parallel lines going on in the shapes, and you've got to use them.